Hi friends, today we are learning about current electricity under these topics. In this topic, color codes are in not there for this year. First topic is electric current. Electric current is defined as charge flowing through any section of the conductor in 1 second. It's called as electric current. Cross section in any section. Suppose this section flows of electric charges per second is. If rate of flow of charge is steady, I is equals to Q by T. If rate of flow of charges varies with time, it will be dQ by dt. Different types of current. Steady current, which does not vary with time. Varying current whose magnitude varies with direction. Like A is a steady current, which does not vary with time. B and C. It varies magnitude varies with time. B and C. Alternating current whose magnitude varies continuously and periodically, like this. Okay. In C it does not vary with periodically, but in D it varies with periodically. If we see, next topic is conventional current. If positive charge in conventional current flow direction of the positive charge in this direction, electric field also in this direction only. If negative charge in one direction, electric field is acts opposite direction. This is called as unconventional current. Drift velocity is defined as free electrons get drifted towards the positive. This is positive involves free electrons are drifted because of electric field. Okay. Next. Current is directly proportional to the drift velocity. Okay. Formula will be I is equals to NE. Please remember this formula. Okay, let's talk about the resistance. Resistance of a conductor opposite offer by a conductor to flow of current through it. R is equals to potential difference by current. Resistance is directly proportional to length of the conductor and inversely proportional to cross-sectional area. It depends on the nature of the material. Resistivity depends upon the nature of material and not on the geometrical dimensions of the conductor. Then this formula also. Next topic is current density. Current density at a point within the current is the current through a unit area of the conductor around the point, provided an area perpendicular to the direction of the flow of current at that point. Current density symbol is J. J is equals to I by A. Current by area of the conductor is equals to number of electrons into electric charge into drift velocity. In vector form, current is equals to current density point area of current. Current density at a point. This is area of cross section. Here we have current density I per unit area. It is called current density. Next, Ohm's law. Ohm's law, current is directly proportional to the potential difference across the two ends of the conductor. This is positive terminal, this is negative terminal of the conductor. Current flow from the positive to negative. When physical conditions such as temperature, mechanical strain remains the same, current is directly proportional to potential difference across the cell. V is equals to resistance into current. Okay, graph will be straight line. These relations are very important. Please learn this. When temperature is increases, drift velocity decreases, resistivity will increases, and current is increases, drift velocity decreases. Okay, next topic is conductance and conductivity. Conductance is reciprocal of resistance. SI units are more. Conductivity is reciprocal of resistivity. Temperature dependence of resistance. When temperature increases, the number of collisions increases due to internal energy, and realization time decreases. Therefore, resistance is increased. That's why resistance is inversely proportional to temperature. By this formula, temperature coefficient of resistance alpha is equals to RT minus R0 by R0 into T. Temperature. If resistance of second conductor is less than resistance of first conductor, then alpha is negative. Series combination of resistance in which R1 plus R2 plus R3, R is greatest of all. Parallel combination. 1 by R is equals to 1 by R1 plus 1 by R2 plus 1 by R3. R is smaller than the smallest of all. For example, R1 is 1, R2 is 2, R3 is 3. If resistance of series combination is equals to R1 plus R2 plus R3, 1 plus 2 plus 3 is equal to 7, which will be 7. It is R is greatest of all. Electromotive force. Electromotive force is the maximum potential difference between the two electrodes when no current drawn from the cell. This is called electromotive force. Difference comparison of EMF and potential difference is electromotive force occurs maximum potential difference between two electrodes of cell when no current drawn from the cell when it is in open circuit. Potential difference of potentials between any 2 points in a closed circuit. Please learn this different comparison. Then next topic is internal resistance of a cell. Internal resistance, opposition offered by a electrolyte of cell, flow of electric current through it. It is called internal resistance. In this circuit, current is flowing. In this we have small electrolyte with small resistance smaller and electric charge E and potential difference small v. Internal resistance is depend on nature of the electrolyte. Greater the conductivity of the electrolyte, lesser the internal resistance of the cell. Okay. Internal resistance of the cell depends on the nature of the electrodes also. Okay. Potential difference across the circuit is equals to potential difference across a resistance and potential difference across a internal resistance is equals to current into resistance plus current into internal resistance. This formula, current is equals to electric field by internal resistance plus resistance. It is also called as circuit equation. cells in series combination. We have cells in series. Cells are connected in a series. They join ends to ends so that same quantity of electricity must flow through the cells. Same electricity must pass through the cells. EMF water is sum of the individuals of EMFs. The current each cell is same as identical with the current of the entire arrangement. Total internal resistance of battery is sum of individual internal resistance. That is, total EMF water is equals to N into E. N is the number of identical cells present in this series combination. Total internal resistance of a battery is N into internal resistance. Number of identical cells into internal resistance. Total resistance of the circuit is resistance plus total internal resistance of a battery. That is, current I is equals to number of identical cells into electric field in a circuit in a cell by total internal resistance plus resistance or total resistance of circuit. If resistance is smaller than total internal resistance, then I is equals to electric field by internal resistance. If total internal resistance is lesser than the resistance of battery is I is equals to N into electric field by resistance of circuit. Next, if conclusion is when internal resistance is negligible comparison to the external resistance, then cells are connected in a series get maximum current. Next topic is cells in parallel combination. Cells are said to be connected in a parallel combination when they join positive to positive, negative to negative, such as current is divided between the cells. The EMF of the battery is the same as that single cell. The current of the external circuit is divided equally among the cells. Potential difference across single cell is same as the all cells. In this condition, the reciprocal of the total internal resistance is sum of the reciprocal of the individual internal resistance. The total EMF of the battery is E, same as single cell. Total internal resistance of battery will be internal resistance by N, number of individual cells in parallel combination. Total resistance of the circuit is equals to total internal resistance of the battery plus external resistance. Here there is a conclusion. An external resistance is negligible in comparison to internal resistance, then cells are connected in parallel combination get maximum current. This is very important point. Okay friends, this is all for this session. Let's meet in the next session.
So guys, you can avail this PDF through the link which is provided in the description box. Thank you.